All right, today's video is for Biosphere 3. We're going to talk about population ecology. But first things first, go ahead and answer the questions you see here. What is a keystone species and why are they important? So this comes from your video from yesterday. Okay. So talking about population ecology, that's our first thing today. So we're getting more individual here. We're not quite to one specific penguin, as you see here, but we're talking about the population of penguins or population of any species in general. So a population is the number of individuals of a species in an area, and the available resources they have are going to affect how that population grows. And some of those limiting factors can be abiotic or biotic. Okay, so it could be a lack of nitrogen in the soil. It could be a lack of things that will take in carbon dioxide. So it could be a lack of plants. That's going to depend, or that's going to affect how a population will grow, reproduce, and continue to thrive and live in that area. So one of the things that affects population growth, obviously, is the birth and the death rates. So birth rates, those are called natality, and death rates, those are called mortality. Okay, so how many of that population is being born each year compared to how many of that population are actually dying off in that year. Immigration versus emigration. So individuals moving out or moving into a population. Immigration, that's moving in. Emigration, that's moving out. So migrate or migration, that's a seasonal movement. So think about birds fly south for the winter. So it's a seasonal movement into and out of an area. So it temporarily will affect population size. So for example, it's getting on to be December now. Okay, it is December. It's winter. All of those birds that can't handle the cold temperatures here are going to migrate south. So that population size will decrease during our winter months. Whereas during the summer months, when all of those birds come back, that population size for this area is going to increase. So how do we calculate population growth? It's determined by the following equation. Okay, so you take the birth rate for that year and you add it to the immigration rate. So what's coming into the area. Okay, and then you're going to subtract that from the total of the death rate plus the immigration rate. So what's going out of the system. So everything that's coming in minus everything that's going out. Growing populations are going to have a positive number when you do that calculation. Shrinking populations, those that are going extinct, okay, those that are becoming endangered, are going to have a negative growth rate. Now, it doesn't mean that just because it's negative that they are now endangered, okay? It means that they had more of their species die off in that year than they had grow in that year. Okay, so keep that in mind. And we'll talk more about that in just a minute. So there are a couple of different ways that population can increase. Exponential growth is the first one. So population increases by a fixed percentage every year. Now this is a percentage, okay? So this is not going to be linear. It's not going to add 5 new babies every year and take away 2 old penguins every year. So it's not linear. It's going to be a curved graph. And it occurs when you have small populations that are introduced to an area that has the ideal or the perfect environmental conditions for that group or for that population. But here's the downside. It rarely lasts a long time. Okay? Exponential growth is something that is happening in short bursts. Okay? So look at this image. You start out with like almost nothing. You add a burst of, you bring in new population to that environment. It gives it that just short time frame of growth. And then it kind of peaks. Okay? And once it peaks, it's not going to grow anymore. And this is where we come into what we call logistic growth. And this is where you have a population that involves an increase in the number of individuals until you have a limiting factor that causes that population to stop growing. Okay? And what we call that limiting factor is when they're going to reach what's called a carrying capacity. And that's the ideal number of species that can live in an ecosystem and still thrive. Okay, so take a look at the logistic growth. You have that exponential curve to begin with, but then your resources are going to start diminishing. And as it starts diminishing, there is a specific number, K, or the carrying capacity, that an area can hold before some or all of those resources will start being depleted completely. And if they're depleted completely, then this growth chart is actually going to soar and zoom back to the bottom where there's really nothing left because there's no resources there to continue to help those things live. Okay, and this is what the human population is sitting on, is a logistical growth chart. So what we have where we have carrying capacity, a lot of things come into play. Competition is the first thing. Okay, so organisms that seek the same limited resource. So if you look at the image down here on the right of the zebras, okay, you can see they're sharing a water source. So guess what? If they have an overpopulation of zebras and other species that are trying to get to this water source, that water source is going to be depleted, and it's going to force these animals, these species, to move to a different region. Okay, in rare cases, one species can entirely exclude another from using the resource. Okay, this is not very common, but it is rare. Okay, so it does happen on occasion, but not very often. So for example, if we had, maybe there are hippos or alligators living in this body of water here, and let's say that the zebras come to understand that they have alligators or hippos in this area, and they're going to stay away from it. So that would exclude them, if they're smart enough, right, to stay away from that one resource. So we have what's called predator and prey effect. They grow and help determine the carrying capacity. So we have, they're going to kind of take turns about. If you look at the chart here, you see the number of wolves compared to the number of moose in an area over the years. And it's very rare that they are at the same point together. So the last rate that we had was roughly about 1993-94 for this image. It shows that there is a huge number of moose in that area and a very small number of wolves. It's because they can't really thrive together. Okay? So there's very few instances where they do thrive together. You can also see we have a lynx chasing a rabbit in the top image, and we have a gull or a bird being taken in by a shark in the lower image. So again, that's predator and prey affecting how populations will grow. So we have a couple of different relationships. They're called symbiotic relationships. The first one is mutualism. Both species are going to benefit from this. So they are helping each other to grow in population. Okay, so your example is a bee. Bees pollinate your flowers, and your flowers provide food for the bees. They're sharing in what they have so that both can grow in population. We also have what's called commensalism, and that's where one species benefits, but the other doesn't. Okay? So, for example, a mite, I don't know if any of you know what a mite is, but a mite is a very small, it's kind of like a gnat. Mostly find them around chicken houses or such. Huge farms. So mites attach to flies for transportation. Okay, the mite benefits because it's getting moved from one place to the other, but the fly, it doesn't bother the fly in the least. It's neither helped or harmed in this case. So that's commensalism. One benefits, but the other one is unaffected at all. Then we have what's called parasitism. Okay, this is where one species benefits, but the other one is harmed. Okay, so this is a hurtful relationship here. So for example, fleas. Fleas are benefited by feeding on dog's blood. Okay, so when dogs get fleas, it's a good thing for the flea, but for the dog, it's a bad situation. Okay, not only is it a bad situation for the dog, but it can also be a bad situation for humans or the owners of the dog. Okay, so for example, not all dogs are affected by fleas the same. Some dogs are actually allergic to the saliva that a flea emits when it bites, and it can cause rashes, infections, huge scabs, scars on the dogs. So that's harming that dog. Not only is it getting bit by a flea, excuse me, but it is also being allergic to it. Okay, so it's not beneficial at all for the dog. All right, just a couple more things and we're done for today. Talking about human population, and we'll do a kind of a short lab with this in just a little bit. The human population increase occurred really slowly until about 1850. When we had the Industrial Revolution, we had modern medicine started to increase, human survival, and the lifespan of a human actually started to become longer. So roughly today we have a lifespan of about 70 years old, between 70 and 80 years old. That's the average lifespan. Some people live longer, some people don't live that long, but that's the average lifespan today. Obviously, modern medicine has greatly improved since 1850. Industrial Revolution, that's not quite as big now as it was. And human survival rates. We don't really have to do a lot to survive these days. Okay, a lot of what we have, our food, our water sources, you can find in abundance. So if you look at this image, a long, long time ago, back before, before Christ BC, we have very slow population growth, less than 1 billion people in the entire world. Okay, but once we reached about the Middle Ages, the end of the Middle Ages, right after Black Death, the plague, before we reached the modern age, which is what we're in now, you can see that the growth was absolutely exponential. Okay, we are now above the 8 billion mark. So in this world, there are more than 8 billion people. That's a lot. Okay. So if you think about what we said earlier about consequences and having a carrying capacity, too many humans can actually have a harmful effect on the health of our planet and the organisms on it. So that's why now we have a lot of the electric cars, the low fuel emissions, trying to be eco-friendly for our planet, not being wasteful, recycling, reducing, reusing, all of those because of the number of humans we have on Earth. Okay, and it is having a harmful effect. So just kind of be mindful with reduce, reuse, recycle. If you leave a room, turn the light off. If you're not watching the TV, turn the light off, turn it off. Unplug something if you're not using it, because even if it's plugged in, it's still drawing some of that power source. Okay, so keep that in mind, but that is it for today.